converting analog to digital signals, or the topic of sampling. So if we're going to represent nature on a computer system, and nature, remember, is analog, a computer system is digital. So we have to convert from analog to digital signals. Sampling is how we do that. So here's an example. I've got 3 sampling rates. Let's say that these are, I don't know, some fraction of a second. Let's say these are milliseconds. And if I take a sample at this point and then another sample in 1 millisecond later and another sample another millisecond later, well, I can represent this curve, kinda, right? This doesn't look very much like that curve. And this sound, if this were some sound, it would sound choppy and tinny and just really not very understandable. But if I double that, this one I think was about 15 samples, so let's say 15 milliseconds. Well, in this same 15 milliseconds, if I took 30 samples, then I can represent points that are kind of in between. Rather than just here and here, I could now represent a point halfway between here and here as well. And then I would get, well, it's starting to look a little bit better. It's starting to look a little bit more like a curve. If I make that even bigger, this one's around 70 samples in that same 15 milliseconds. And now you can see it's starting to look a lot like the analog curve. So first of all, we have a couple things going on here. In the first place, we have more frequent sampling, so we can represent more points on this curve. And the second thing is, I've got different values, whereas here I only had values that represented this and the one up above it here. But down here, I've got a value between that. So I've got more values that I can use to represent this curve. That happens a lot in colors, for example. So if I have only 8-bit color, that is to say I only use 8 ones and zeros to represent color, I get this kind of low resolution because I can't distinguish between, say, this dark green and this green next to it. But here, if I have 64-bit color, I've got 64 ones and zeros. I've got 4096 possible colors, and so I can get those finer details in between that. It looks much more like actual nature here because I got smaller steps that I can choose from when I go to convert that sample from analog to digital. Well, that's it for analog versus digital sampling. But of course, remember that this is also true of sound, color, loudness, brightness, and just about any other characteristic you can think of.